In this section, we will see a high-level introduction, you can say, related to the virtual port channel technology. Okay, so the very first point is the VPC belongs to the multi-chassis ether channel like VSS. So if you are familiar with the VSS technology, so it's more like you can say a advanced version of the VSS technology, or you can say that Cisco had taken the VSS to another level. Okay, so there are no more spanning tree block ports. So in the VSS, I mean in the VPC, now we don't have any block ports as far as the spanning tree is concerned. It provides the fast convergence upon the link failure or the device failure. So it means that if there is any link failure from the, if any server, let's say if any server is connected to your VPC devices and one of the link fails, or let's say all of your VPC device goes down, then it provides a fast convergence. Okay, and your network design is more simplified into the virtual port channel. We'll see all these details. Now let's see what some benefits of the virtual port channel. So into the VPC, each peer device they runs their own control plane. Unlike if you talk about the stacking or the VSS technology, in those two legacy technologies, the devices were using a single control plane, right? But in VPC, each device will run its separate control plane. So it means that if there is any issue in the control plane of one peer or one device, then it is not going to impact the another device, right? So that is the benefit. So now let's look at this diagram. So we have the stacking. You can see here, the first one is the example of stacking, wherein you can see we have two switches, as switch 1 and switch 2, and let's say we have one server or any device ABC which is connected to the uh, stack switches, right? So in stacking also, why we say that we do have a single control plane. So whenever you log into a master switch, or you can say whenever, let's say you are having two devices into stack, when you log in, you do have only one management IP, right? Let's say this switch is having management IP 10.1.1. So whenever you log into the device, you log into the master switch, irrespective of the number of devices you are using into the stacking, right? You never see like this that you have maybe four or five switches into the stack, and you are using the separate management IPs for all the switches, right? So you just connect all the switches via the stack cable, and you just give one IP address, and whenever you log into that management IP, you will land to the uh, master switch, right? Same is the case with VSS. In VSS also, only let's say switch 1 is the master switch and switch 2 is the backup switch or the standby switch. So in VSS also, only the master switch will be accessible via the management IP, right? When you give the management IP to the VSS switches, so only the master will be accessible, right? So it means, it signifies that ESS and stacking, these two technology, they use the single control plane, right? Also, uh, let's say this is some layer 3 device, and let's say we are running OSPF between the stacking switches and the layer 3 devices. Let's say we are using OSPF area 0, okay, between these two devices, and let's say you are at this layer 3 device. If you do a show IP OSPF neighbor, then you will see only one neighbor, okay? It, because the devices, they are using the single control plane, that is why. Same is the case with VSS. Let's say this is a one layer 3 device and we are running any layer 3 protocol, let's say OSPF. If you do a show IP OSPF neighbor here, then you will see only one device, because in VSS also we are using the single control plane, but this is not the case into the VPC technology, okay? In VPC, both your switches will be having a separate management IP. Let's say this device is having management IP 10.1.1 and switch 2 is having the management IP 10.1.1.2, let's say, okay? So because in VPC we are having the separate control plane, that is why both the devices they'll be using the separate management IP. And let's say this is some L3 device, ABC, and we are running, let's say, OSPF, then this device is going to form two OSPF neighborship, one with switch 1 and one with switch 2. So if you do a show IP OSPF neighbor here on ABC, then you will see two OSPF neighbors. So that is why you can see that in VPC we are using a separate control plane for both the peer devices. That is why if there is any problem into the control plane of one device, it is not going to be populated to the uh, second device. So that is the benefit of the virtual port channel. Okay, let's see what's next. So in 2009, Cisco introduced Nexus 7000 switches into the market, and since then the VPC technology is supported into the NXOS 4.1.3 and the later version. Okay, and for VPC, we do not need to buy any extra license. So it comes with the NXOS software license. Okay, it's already included in that. So you don't need to purchase anything extra for the VPC. And VPC is a layer 2 technology. We cannot have the layer 3 port channel into VPC. What does it mean? It means that, let's say we have switch 1 and switch 2. Okay, and we are using the VPC. So let's say this port is 1 by 1 and this port is 1 by 2. So both these ports will put these ports into a port channel. Let's say we put them into port channel 1, and then uh, with this port channel 1 we'll put this port channel into the VPC. Let's say we put it into VPC 1. Okay, so you cannot do like that you use interface port channel 1 and you give some IP address to it, let's say 1.1.1.1 something. So you cannot uh, form a layer 3 port channel, and you cannot use it with a VPC because VPC is a layer 2 technology. Okay, so we are just it's a, you can say it's a layer 2 virtualization technology, so it's not included into layer 3. So if you are forming VPC between two peer devices, then you can only form a layer 2 port channel. Okay, so only you can just say either you can use the switch port mode access or switch port mode trunk. That's it. So just keep it in mind, because I have seen people a lot of time they are not aware about this, and whenever you ask them that if there is any layer 3 port channel, can we do a VPC, and most of the time they will say yes, we can do that. But this is not the correct answer, because VPC is a layer 2 virtualization technology. You cannot form a layer 3 port channel and put it into the VPC. Okay. So for the virtual port channel or the VPC, the peers must be identical. So the two devices that you are going to form the VPC, so they must be of the same model, and they must use the same modules or the line cards, etc. So there are some exceptions, like in the Nexus 7000 series, we can on one side you can use, let's say, Nexus 7000, and the second peer device you can use 7700. Okay, the second bullet point you can see Nexus 5500 and 5600, they are not allowed into the same VPC. Okay, we can use the mix and match of the supervisor engines. For example, Nexus 9K, we can use soup 1 and soup B, sorry, soup A and soup B. In Nexus 7K, we can mix and match between the soup 1, soup 2, or soup 2E. But most of the time, in the live network, you will see that yes, we can. You can easily see. You can frequently see these mix and match of the soup engines, but for the model numbers, most of the time, in more than 90% of the cases, you will see that we use the identical switch models. Okay. There are some terminologies into the VPC. Okay, so There are some terminologies into the VPC that you must be familiar of, or if you're not familiar, then you will be familiar once we finish this VPC series. So the very first thing is the VPC. VPC is nothing but a port channel, okay, between your peer devices and your downstream devices. The second point is the VPC peer device. So the devices that are involved into the VPC, we call them the VPC peer. Okay. Next one is the VPC member port. VPC member ports are nothing but the ports of the port channel, right? What does it mean? It means that let's say this is our one device, right? And they are forming the VPC and not VPC. So this is the peer link. We'll discuss it later. Let's say this is your switch one, this is your switch two, or peer one or peer two. There is one downstream device, and they are forming the VPC. So these ports, let's say this is port number one by one, this is port number one by two. So these one by one and one by two, they are forming one port channel, let's say port channel one, and we put this port channel into VPC. So they are forming a VPC with this downstream server, let's say X. So these ports one by one and 1 by 2, which are a port of this port channel which is into VPC1. So that is called the these ports, we call them the member ports or the VPC member port. Okay, and these devices we call them the VPC peer device. Okay, let's see what's next. Cisco Fabric Services. So Cisco Fabric Services is a protocol that is running in the background between our peer devices. And what is the use of Cisco Fabric Services is that it will do the configuration validation and comparison between the two devices for the consistency check. We will see in details what exactly is this consistency check. For a high level of overview, you can think of it like this. Let's say you have your two devices. Let me grab the pen. So you have your two devices, switch 1 and switch 2, right? So between this link, this is a port channel which is called the peer link, okay, between switch 1 and switch 2 or your VPC peer devices. So into the background over this peer link, there is a protocol called Cisco Fabric Services which is running into the background. And what is the use of Cisco Fabric Services? That it is the first bullet point, as you can see here, it will do the configuration, validation, and comparison. Okay, so the configuration between both of your peer devices must be identical. For example, if you're running rapid spanning tree on switch 1, so you need to make sure that you're also running rapid spanning tree on switch number 2. If you use, let's say, multiple spanning tree here or RSTP here, then it is not going to work, because into the background Cisco Fabric Services protocol is running, and it is consistently checking your configuration, and it is doing the comparison. Okay, so if you use different spanning tree modes, it is so CFS is going to know that, and your VPC is not going to work. Okay, and also it is responsible for the synchronization of the MAC addresses for the VPC member ports. So let's say these two devices, they are forming a VPC between the this is one of your device, let's say 123, they are forming some VPC here, let's say VPC 10. Okay, so all the MAC addresses that they are learning on their member ports, so the MAC addresses will be synchronized via this peer link, okay, by CFS. All your HSRP messages, your ARP table entries, your IGMP messages, so they will be synchronized using this peer link. And who is responsible for that? CFS, Cisco Fabric Services. So you do not need to run any extra command to run this protocol, because it's already there into the background whenever you just enable the VPC between your peer devices. So it will come into picture, and it will do its work. Okay. So VPC Peer Link. So VPC Peer Link is we just draw it right in our previous diagram. So between our switches or between our peer devices, we have switch 1 and we have switch 2. So we'll form a port channel between these two devices. So this will be our peer link. Okay. Peer link will be used to synchronize the state between the VPC peer devices. So CFS will run on this peer link, right? And it is going to synchronize the states or the app table or the MAC table or your IGMP or be it your HSRP messages. So all will be synchronized using this peer link. So it must be a 10G link. Okay. So if you're using 1G link between your two devices, then you cannot form a VPC peer link. So on 1G links or on the fax links, VPC peer link is not supported. So you must be having 10G link only if you want to form a VPC peer link. Okay. And VPC peer link is a layer 2 trunk carrying the VPC VLAN. That we will see next. What are these VPC VLANs and all? Okay, so VPC domain ID. Let me clear the drawing. So VPC domain ID. So whenever you will configure the VPC, so the very first step is first of all you are going to enable the feature, right? So in Nexus, if you're familiar with the Nexus technology, then there are a lot of things that your lot of features that are not enabled by default. So you must give the command or you must enable the feature first, right? So VPC domain. So when we will form the VPC, the very first step is the VPC domain ID. Okay. So first of all, we need to configure the domain ID, and that domain ID, the VPC peer devices will be used to create a LACP ID, which the devices or the VPC peer devices, they are going to use it to fool the downstream devices, because for the downstream devices they are presenting themselves as a single device, right? So using that domain ID, a LACP system ID will be created, and that LACP ID the VPC peer devices are going to use. So if you go to the downstream switch with which the VPC peer devices are forming the VPC, and if you do a show LACP neighbor, you are going to see this particular LACP ID. Okay. And this particular LACP ID will be derived from the domain ID. That we'll see into the practicals, how exactly it is inheriting this particular domain ID into the LACP and all. Okay. The next one is the VPC Keep-alive. So VPC Keep-alive is nothing but a link or link between the VPC peer devices, or you can say it is used as a heartbeat messages between the two devices. Okay. And what it is using the port number 3200. It's a 96 byte long packet uh, that the VPC peer devices use as a keep alive, and the payload value in that particular packet will be of 32 byte. As long as the peers are reachable, it works fine. It means that if you're having your two devices, okay, let's say this is switch number 1, or this is your peer 1 and this is your peer 2. So let's say you connect one more link here, and you have IP 10.1.1. Here you give IP 10.1.1.2. So you are using a L3 connection between your peer devices. So as long as these two IPs are pinging each other, it works perfectly fine. So you can also do like this, that instead of directly connecting this two VPC peer devices to form a VPC keep alive link, it's also possible that you have some WAN connection here, right? And you have some IP here, let's say 10.1.1, and here you have some another subnet IP, let's say 20.1.1 or 20.1.1.2. So as long as this 10.1.1 and 20.1.1.2, these are reachable, the VPC Peer Keep-alive link works perfectly fine. Okay, there is no requirement that these two IPs must be of the same subnet, and this is used as a heartbeat message. It is going to it keeps on checking whether our devices are alive or not. So there are a lot of conditions, and we'll see a great use of VPC keep alive when we'll do the failover scenarios. So we'll see how exactly this VPC keep alive link works. Okay. Next is the VPC VLAN. So VPC VLAN are the VLANs that are allowed on the peer link. Okay. So what it means is that, let's say you have your peer devices 1 and 2. So if you, let's say you create one VLAN here, VLAN 10 and VLAN 10 here. So that VLAN will be allowed on the peer link, right? So VPC VLAN is a VLAN which is available on both of your devices, and that is also allowed on the peer link. If you, let's say you create one VLAN 20 here, okay, and you don't create the VLAN 20 here, then this VLAN 20 will be pruned, or that VLAN will not be allowed on the peer link. So this VLAN is not the VPC VLAN. Okay, VPC VLAN is a VLAN that will be allowed on your peer link. Okay, next is the orphan ports. So orphan ports, you can think of it like this. Let's say there is one server here S, which is connected to both your peer devices, and you have formed one VPC here, let's say VPC2. Okay, and there is one another server here, let's say X, which is connected only to peer number or switch number 2 of your VPC peer. Okay, so because this server X is not connected to the another peer or switch number 1, and you are not forming any VPC, so this port here, let's say it is 1 by 3, so this port will be called as the the orphan port. And the condition is that the VLAN which is allowed on this, let's say here we are using VLAN 40. So VLAN 40 must be a VPC VLAN. Okay, it means that VLAN 40 must be present on both your peer devices, and VLAN 40 must be allowed on the peer link. So orphan ports, it means you can just think of it like that, that a device which is connected single connected to either of your VPC peer device, and it is using the VPC VLAN. Okay, if you're using any VLAN, let's say we took the example of VLAN 20 which is not allowed on the peer link, and let's say this port is in VLAN 20, then you cannot say that this is a orphan ports, though this is single connected, but it is not using a VPC VLAN, so it will not be called as a orphan ports. Okay, so this 1 by 3 will not be called as an orphan ports. So orphan ports uses the VPC VLAN. Okay, here. So VPC Keep-alive we already talked about, right? It is used as a heartbeat UDP message, UDP port number 3200. So that we already discussed. Now let's look at this diagram. So let's say this is our Nexus 7K1, right? This is Nexus 7K2. So these are your two VPC peer devices. So this design is not supported. Okay, so you cannot use any switch in between your peer devices. So your devices must be directly connected. Okay, so you just need to make sure. This was a little information. And into your VPC domain, there is no spanning tree. There are no block ports. Okay. For example, if you look at here, Just forget about this blocked by spanning tree. Just think of it. Let's say this is your VPC 10 and this is your VPC 20, right? So this is one switch. Let's say this is switch number 1, this is switch number 2. So switch number 1 is connected to N7K1 and N7K2, right? So this is a port channel. So in port channel, both ports will be in forwarding state, right? And this is the peer link between your peer devices, and peer link will always be into forwarding, right? And which makes sense also, right? If you block the peer link, then how these two devices will synchronize with each other, right? So that is the default behavior, that your peer link is not going to be blocked. Okay, so if you talk about the connection between this server or this switch, let's say this is switch 1. So between switch 1 and your peer devices, you can see this port is uh, into forwarding, this port is into forwarding, and because this is the port channel, these two ports are also into forwarding, and this is a part of port channel or the VPC. So these ports are also into forwarding. So into a VPC domain, there is no concept of the blocked ports. But if we are going beyond the VPC, then spanning tree is always there. Okay, like this example. So between these your switches, let's say this is switch 1 and this switch 2, let's say that you are using a one more connection here. So now you can think of the logical diagram of this topology will be like this. So this is the, because we are using the VPC, right? So this is nexus your N7K1 and 2, right? They are behaving as a single switch, and they are connected to your switch 1, and this is your switch 2. Now they are forming a triangle, like we already studied in our basic data center technologies like spanning tree, right? So now this particular link is going to be blocked by the spanning tree. So if you're going beyond the VPC, then spanning tree is always there, but within a VPC domain, none of your port will be blocked. Okay. So this was a high level overview. So in our next section, we will see how we can form a VPC. We'll do a practical of that, and then we'll do the step-by-step configuration, how to configure a VPC peer keep live link, what are the different steps that we must follow, and what are the different requirements for the designs that are supported and which are not supported. So we'll go into the details of that. Okay, so see you in the next section. So if you like my videos, please like and subscribe my channel and click the bell icon so that you'll get the notification for my next video. Thank you.